Camera never starts. Okay. Good, it's on. So here's 2.3. This is titled Real Zeros of Polynomial Functions. So when we're talking about 2.3, for the most part, there's going to be one thing that we really need to hit on, and that is synthetic division. So synthetic division is something you've seen before, but likely don't remember how to do. The purposes of synthetic division is going to be factoring polynomials. That's one way that you can factor. If you have a very large polynomial, say something of like a 5th or 6th degree, that you aren't very comfortable trying to factor on your own, or even would just find it too hard to even do so, you can use synthetic division to go ahead and do that factoring. And that's something that we'll move on to more in section 5. Obviously, dividing is one of them. You can divide any polynomial by another polynomial using synthetic division. And then on top of this, if we're finding factors, we're likely also then finding zeros of a function. So synthetic division gives us a really quick way to shoot in what we think might be a zero and pop out a yes or no answer to that. So those are the two things right here that we're going to focus on today. Factoring is going to be something more in the future. So we're going to do a quick review of even how to perform synthetic division. Let me get myself some room. So when we're doing synthetic division, let's first start by dividing. So we're going to use synthetic division to divide f of x equals, you can see it over here, 3x cubed plus 8x squared plus 5x minus 7. Okay, and we're going to divide that by x plus 2 equals 0. And you would likely not see it that way in the book. So I'm just going to leave this as x plus 2. So when we set up synthetic division, my first thing I want to check for is, am I missing any placeholders, or am I missing any terms, basically? So when we set up synthetic division, just like you would have remembered maybe setting up long division, you have to set things up in that standard form, so in order. So when we have to work our way down from one exponent to the next, to the next, to the next, if there's any missing, we need to put a 0 placeholder in there. So we start with an x squared in this function, then we move down to an we start with an x cubed, then we move down to an x squared. So I went from 3 to 2, so I'm not missing anything there. From 2, I go to just an x, which is x to the first, so I'm not missing anything there. From x, I go down to my constant. So in this case, I'm not missing any terms. So I'm going to write in here that I don't need any 0 placeholders. And I'm writing that mostly just so I know that I've done the check. I remember to do that, and I don't need any 0 placeholders. Second thing is I need to figure out what is that number that I'm actually dividing by. So we're not going to divide by this whole x plus 2. I need to see what's outside of my division. If you're thinking or trying to remember what even was synthetic division, it's set up in this form with this kind of half of a rectangle shape. So I have to figure out what's going to go on my outside here. What's that specific number that I'm actually dividing by? So what happens is we do set this up equal to 0, and then we solve for x. In this case, that's really easy. It's just subtracting over 2. Whatever's on the right side of this equal sign is what goes on my outside of the synthetic division kind of bar here. So now I take the coefficient and constant. So just the numbers, not the x's, not the variables. I take just the numbers and I line them up here at the top. What's important to remember is signs come with it. So this is a +3, +8, +5, but -7, right? Whatever sign was attached to it in front is going to come with us. First step in the actual process in synthetic division is your first term comes straight down. We do nothing else with it, it just comes straight down. Then what happens is we do this process where we take our number in the bottom and we multiply it by the number outside. So 3 times -2. That gives me -6, and that number comes over here. Now I add straight down. So I'm adding 8 plus -6. That number comes down, I get +2. Okay, so that's kind of one full cycle of a synthetic division. Now again, I go with this bottom, multiply it by my outside, 2 times -2. That gives me -4. That number goes over here. Again, I add those two up and that number comes down. 5 plus -4 is 1. I keep this cycle going. Number in the bottom, multiply by my number outside, -2 times 1 is -2. That number comes over here. And I add those two up. That gives me -9. I have no other numbers over here on the right side, so I'm done. My last step is just simply writing what is my actual product of this division, right? What's this quotient here? What did I finally get when I was done with this? So we start from our right side and we work our way left. This first number on the right side is always my remainder. Always, always, always the remainder. This is your constant, right? A constant is just a number without a variable attached to it. Nothing else. Third term is going to have my x attached to it. And then I just start working my way back up. The next term in will have an x squared. If I had more terms, I would go x cubed, x to the 4th, x to the 5th, right? I just keep working my way up. This is why we have to work our way from our right to our left, is because we have to have remainder constant, then work our way up. So if I write this all out, I would have that my starting polynomial divided by that x plus 2 gives me 3x squared plus 2x plus 1 minus, right, this remainder. We're actually going to call it a plus a -9 over, right, since my remainder was 9, we take our remainder over what we divided by, which was x plus 2. So we go ahead and we write that up there. And that's what that entire division process gave me. So this is the process of synthetic division. But something we're going to use it for specifically today is finding out if something is a factor, which if it's a factor, then it is a 0. One thing that I just want to mention is we have this thing called the remainder theorem. It's not the most important thing you're going to learn from synthetic division, but one thing that might end up helping you at some point in time. With the remainder theorem, it's stated basically that the number that I'm dividing by, so the number out in front, with the number that's in my remainder is a point on my graph. Okay, definitely not the most important thing for you to know that -2, -9 is a point on your graph. Moving forward, when we're talking about zeros, that will be an importance, right? Because if this number is 0, then that will be a 0 on my graph. But again, that's what we're moving toward here in just a second. But it is just a good thing to know that this does create a certain point on your graph, okay, with that remainder theorem. So again, we're moving on to determining, helping, or making synthetic division help us determine whether or not something is a 0. So the prompt for this one, I'll move this camera back up, is going to be that I want you to show that the factor x minus 2 and x minus 3 are factors. In parentheses, basically a factor is the same thing as zeros of the function f of x equals, I'm going to bring this up here because it's a long one, 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. Okay, so again, that's a long one. Your first instinct should be that I don't want to factor this, right? I want you to find this algebraically. If I want you to find it graphically, I will tell you. But I want you to find this algebraically. So that being said, my process of finding out if something's a factor would literally be to factor this out. I don't want to do that. Not only do I not want to, I don't exactly know how to start that out. That's not something that we've learned in here, is to factor a polynomial that looks like this. So instead of trying to factor this, we can use what we just learned. I can use that synthetic division to try to determine if these two things are factors. So the factor theorem basically states, if this factor or if this factor is truly a 0 or a factor of this function, my remainder will be 0. So I'm going to write that off to the side. If they are factors, the remainder of the synthetic division will be 0. Okay, let me twist you over that way for just a second so you can kind of see that. Again, just a little asterisk. If they are factors, the remainder of the synthetic division will be 0. If they are not, then they are not factors, right? That has to be a fact of this. It has to be 0. If it's not 0, then it's not going to be a factor. So we go ahead and we start with the first, determining whether or not I need any 0 placeholders. I go from a 4 to a 3 to a 2 to a 1 to no x. In that, I went straight down in order, so I need no 0 placeholders. Okay, I'm good there. So I'm going to go ahead and set up the synthetic division bar. If I want to test that x minus 2 is a factor, I have to set that equal to 0 and solve for x. So 2 is what goes on the outside of the synthetic division, which I'm just going to move that down because you can't see that too. There you go. You can barely see it now. There you go. Now I take all of the coefficients and constant and line them up top. So 2, 7, -4, -27, and -18. Okay, we're going to start this off by always bringing that first number straight down. I do nothing with it, I just bring it straight down. Now I take these two numbers, multiply them together, put that product right here. 2 times 2 is 4. I go ahead and I add these two up. I get 11. Again, 11 times 2, 22, goes right there. And I go ahead and I add those up. Negative 4 plus 22 gives me 18. Then again, I multiply 18 times 2 to get 36. And I go and I add up negative 27 plus positive 36. This gets me to positive 9. Again, 9 times 2 is positive 18. I add that up and I get 0. The remainder theorem or factoring theorem, whatever we want to talk about, states that if something is a factor, the remainder would be 0 after going through synthetic division. My remainder is 0. So yes, x minus 2 is a factor. But I'm not done. I also wanted to know, was x minus 3 a factor as well? Let me figure out what that would be. X minus 3 equals 0. I would have to set up the synthetic division using 3. So I don't start over. What I do is the next factor I want to test, I continue on with my synthetic division. So I'm not going to reset this up. What I do instead is I put my 3 outside because that's the factor that I'm testing, and I bring down this number, this number, this number, and this number. I do not start all the way back over. I just continue on with the numbers I had left over and keep going with the process. Okay? Oh, let's make one quick adjustment. I actually wanted to ask you, and this is only going to work out if I tell you this. I wanted to know, is x plus 3 a factor? Okay, so go ahead and change that in your directions. That means that this is x plus 3 equals 0, meaning that x equals negative 3. So what I'm putting on the outside is truly a negative 3. Again, I changed this to x plus 3. It won't work unless I do it as a plus 3. Sorry about that. Okay, so we have negative 3 on the outside. So I start off by dropping down this first 2. 2 times negative 3, negative 6. Okay, we go ahead and we add those up. We get 5. 5 times negative 3, negative 15. We go and we add those up to get 3. 3 times negative 3 is negative 9. Add those up to get 0. Again, what this stated was that we wanted to know with that factoring theorem, if my remainder is 0, then what I started with, that x plus 3, is a factor. Remainder is 0, so yes, x plus 3 is a factor. Just to make sure that you do understand what I have left over as well. What's happened here in synthetic division is every time I divide by a factor. So I first divided by x minus 2. Oops. I'll go over here. I'm going to erase all these yeses. So every time I divide by something, that factors it out. So I have x minus 2. Then I divided by x plus 3, right? That was the second one. So then I divided out the factor x plus 3. Now, what's left over is what I have not factored yet. Okay, so let's go through this process again and figure out what's my remainder, my constant, my x squared, and so on. Here is my remainder. That's 0. I have nothing to write for that then. This is my constant. Then I have an x, and then I have an x squared. So this leads to the remaining polynomial as x, or 2x squared plus 5x plus 3, and then plus 0 remainder, so I have nothing. So this is the part that is still left unfactored. This is what I've factored out, and this is what I've factored. So far, this polynomial function of 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18 has been factored to, I'm going to write this over so I can fit everything, x minus 2 times x plus 3 times what I have down here, right? What I have down here, that is 2x squared plus 5x plus 3. Okay, again, one last time. This two-step synthetic division here has so far factored this polynomial into this polynomial. This is factorable. I could keep factoring from here to find the rest of the zeros. Remember, my highest degree is 4, so I can have up to 4 total zeros. I can still get 2 more zeros out of this lasting quadratic function here. Okay? That's what synthetic division does for us, though. It finds us zeros, it divides polynomials, but it also factors them for us. So this kind of two-step synthetic division process is something we're going to continue doing to actually factor things out completely. We're not going to get there yet. This was the biggest thing that I needed you to kind of learn coming out of 2.3. So just a little tidbit. I had originally thought that we weren't going to do a quiz for chapter 2, but looking at chapter 2 a little bit more in depth, there is some things that I want to do that's just going to take a little bit longer than I thought. And it's not fair to you to push off a quiz if it's going to take a couple weeks to get to a test. So just going to pop a quiz in at some point this week, likely maybe Wednesday or Thursday of this week. So just keep in mind that that's going to be coming sometime soon. Honors credit videos are going to be going up, but we will have a quiz for chapter 2 sometime this week, and then follow up with the chapter test a little bit later on. We're not going to go that much deeper into chapter 2. It's just good to kind of get a good quiz in there so that we all know where our understanding's at before we get to a test. Okay, that's it.